Welcome Honors Algebra 2 students. Hey, I hope everything's going well for you. We're going to talk about some more trigonometry here and try to give you some ideas about doing some calculations of trig functions throughout all four quadrants and without using your calculator. So just a quick review. Here are the quadrants, quadrant 1, 2, 3, 4. Old school, we use Roman numerals. Remember Roman numerals? We go counterclockwise, so we start here in the first quadrant, x and y, everybody is positive. When we get to the second quadrant, we go left and then up. So left is negative, up is positive. When we get to quadrant 3, it's left and down. So everybody's negative. For example, the point -7, -5 is in that quadrant. If we go into quadrant 4, we're going right and down. Say we're going 6, -2, so we're going positive, negative. I know you know all of that stuff, but it's a little review and actually it comes in pretty important as we go through the trigonometry. So the possible measures now in degrees, well, we always start here, and we're just going to skip count by 90 degrees. There's 90, 180, 270, all the way around. We're back to 360 where we started. All right, that's just to get you warmed up. Are you thinking and ready to roll today? So we're going to use the definitions of SOHCAHTOA, and we're going to apply them to angles in right triangles, and we'll calculate some values. We'll find the values of sine and cosine, positives and negatives. We'll talk about 30, 60, 90s, 45, 45, 90s. And again, you have to memorize your special right triangles. 45, 90s are 1, 1 square root of 2. 30, 60, 90s, I call them 1, 2 square root of 3. I hope you can picture them. Here's your 45, 1, 1 square root of 2. I like this picture for the 30, 60, 90, 1, 2 square root of 3. Notice the square root of 3 is across from the 60-degree angle. The 1 is across from the 30. Again, little things, but very important. This is what we look like when we get old and we do a lot of trig, and just showing you it shows up all over clocks, compasses, quadrants, and it makes you smile. All right, we're just going to take a look at, you know what, I'm going to speed up the video and we're going to skip these this investigation, and I think we can do it without. Yeah, we're just going to skip it, and now we're going to try. Let's go to a new example. Okay, let's check this out. Well, I'm sorry to here we go. Let's take this point, we're going to draw a segment, and we're going to do the SOHCAHTOA. This will be a good place to start. Sorry about the hesitation there, you guys, but some of my videos have been getting long. So we're going to take a look at this point, and we're going to draw the segment, and we're going to try to find the values of sine, cosine, and tangent. We're going to make this point into a triangle. So if we take the point -3, 1, I bet you all agree it would over there in quadrant 2. It's left 3, up 1. What I'm going to do then is take that point, I'm going to make a triangle to the origin and down to the x-axis. And then you can see I have a right triangle, and I'm going to do SOHCAHTOA with those coordinates. Okay, so here we go. If I go left 3 and up 1, here is my point. Left 3 and up 1. -3, 1. To get the hypotenuse, I think you'd all agree, it's the Pythagorean theorem. A squared plus b squared equals c squared. So we're going to have -3 squared plus 1 squared. So you can see how you get the square root of 10. Okay? Now, if this is my reference angle right here in by the origin, I would label the sides like this. This would be opposite. This is obviously the hypotenuse. And this is adjacent. So if we do SOHCAHTOA, look at the values you get. Sine is going to be opposite 1 over the square root of 10. Cosine is going to be cos, adjacent, -3 over the square root of 10. Here's your adjacent, here's your hypotenuse. And tangent would be opposite over adjacent, 1 over -3 or -1/3. This is something with your calculator. I'm going to skip that as well. Just to refresh your memory too, you guys, we should put this in simplest form. That's the square root of 10 over 10, -3 square root of 10 over 10, and -1/3. To get rid of radicals, remember you multiply the top and bottom by that radical. Square root of 10 times the square root of 10 is the square root of 100, which is 10. Okay? So one of the things you're going to learn today is doing SOHCAHTOA to coordinate values, and we're going to teach you a little bit of a shortcut to that, just in case you don't want to draw all of that out. Okay, here is another example. This is coming from the FST book, Chapter 2. We're in 7.4. All right, we're going to find sine of 300. So over the years, I've had many brilliant students, and they have helped me develop some shortcuts. And one person came up with triple T a few years ago. We're going to draw the turn, make the triangle, and do the trig. All right, 300-degree turn, 0, 90, 180, 270. I'm going to be out here in the fourth quadrant. All right, this reference angle is going to be, here's my 90, this is going to be 60 degrees. So we'll draw it again a little bit better. Here's my right angle. This is a 60 because 300 is 60 degrees away from 360. That means I have a 30, 60, 90, which means I have a 1, 2, square root of 3. Again, you got to memorize those. I'm in the fourth quadrant where this square root of 3 is negative because I went right, positive, down, negative. The hypotenuse will always be positive. So now I go from this reference angle and I do the sine of 60 degrees to get the sine of 300. So here's my 300-degree turn. This reference angle is going to help me out. So if I label my sides, this is opposite, this is hypotenuse. My answer is negative root 3 over 2. So this is called an exact answer. If you typed it in your calculator, you get a decimal of like negative 0.866. But the exact answer is going to use our radicals or square roots. Here are all the steps again. Draw the picture. There's the turn. There's the triangle with the reference angle. And there's the trig. So you're going to get negative root 3 over 2. Those diagrams are a lot better. I'm going to go through them again a little bit slower just in case you're taking notes. You can slow down the video. Turn. Remember triple T. Triangle. Remember this is called a reference angle. And then we do the trig. In this case, SOHCAHTOA. All right? So this reference angle helps us calculate the sine of 300 degrees. I'm going to do 2 or 3 of these and get you into and get the relationship of that coordinate point 2 and not make this video too long. So let's go sine of 135. 135 would be into the second quadrant. There's my turn. If I make the triangle, 135 is 45 degrees away from 180. So 0, 90, 180. Remember my reference angle is the distance there. 180 minus 135 is 45. Then I label my triangle 1, 1, square root of 2. Since I'm in the second quadrant, I am negative, positive. So this would be a negative 1. And then I'm going to do sine from this angle, opposite, hypotenuse. I would get 1 over square root of 2, and we can't leave it like that, so we're going to get square root of 2 over 2. In future videos, you'll see even faster ways to do this, but we want to get you a good picture of what's going on. Okay, let's go down to, well, let's try the next one, sine of 210. 210 is going to take us into the third quadrant, right? Here's 180, so I'm going to go past 180. I'm going to get a new reference angle here. I've got a 30-degree reference angle, because 180 plus 30 is that 210. That would label my sides 1, 2, square root of 3. Third quadrant, I've got negative, negative. So that's why we asked you about those quadrant values. And again, I'm doing sine, which would be from the reference angle, opposite, over hypotenuse. Negative 1/2. You could check that one on your calculator, type it in, it should say negative 0.5. Okay, I'm going to skip this one for now, and I'm going to do cosine of 225. 225 is going to take us into that third quadrant again. 180, 270, I'm in between there. I'm going to go this way. 225 is going to be a 45-degree reference angle, which gives me a 1, 1, square root of 2. And third quadrant, those are both negative. Cosine is adjacent over hypotenuse. Remember, I'm always going from this angle that's in here by the origin, called the reference angle. So it would be negative 1 over the square root of 2 which is, if I can write a little bit better, and hopefully you're good with your radicals, negative root 2 over 2. All right, there's a quick primer on triple T, turn, triangle, trig. And now, what if you have a coordinate? Do you have to keep drawing out all these pictures? And this is what the investigation would have had to explore. But check this out. You can find this degree, and using those points, you can make that same right triangle. And you know you went left 1 and up 2. You can find the hypotenuse by the Pythagorean theorem. I would hope you could do this one in your head and get the square root of 5. If you can't, it's negative 1 squared plus 2 squared. 1 plus 4. So you can see that the hypotenuse is the square root of 5. And then we could do all the trig functions. So here's a little better picture. Negative 1, 2 was our starting point. You can see how I calculated the square root of 5. I'm trying to find this turn right here. I don't know the turn, I don't know the reference angle, but I could now use any of my trig functions to do that. If I wanted to find the reference angle, I could do opposite over hypotenuse, 2 over the square root of 5. I could do cosine, which would be adjacent, negative 1 over the square root of 5, or tangent, 2 over negative 1. And to get negative 1, I would do, well, we could show you how to calculate this, and we will in just a minute. But I think you're getting the idea of how you can use a coordinate. And we're going to show you a shortcut just in case you don't want to draw that picture all the time. So if you take a look at what we did there, we had this point. We had x, we had y. They called this d. Every book's a little bit different. I've used books, they called it r for a radius. This book uses d for the distance from the origin. And if we're going to do SOHCAHTOA, you're going to see that sine is going to be from this angle. Here is going to be opposite over hypotenuse. So look at what sine says, y over d. Cosine is going to be adjacent over hypotenuse, which in this picture it's the x value over d. And tangent would be opposite over adjacent, which is y over x. So what you have to do is calculate this hypotenuse every time, and they use this formula. D is the square root of x squared plus y squared. So we're going to practice this. You're probably a little bit confused, like what the heck is going on? Here's the great thing, you guys. If this confuses you, you can default to drawing the picture. So this is a blown up picture of that little blue box. Sine is y over d. So you've got two things for sine. You've got opposite over hypotenuse. But look at this picture, opposite and hypotenuse. You can use coordinate values too. Cosine is ca or x over d. Tangent is TOA, which would be opposite over adjacent. Here's how you calculate d using the coordinates x and y. All right, let's try a problem. We'll do it two ways. We'll do triple T, and then we'll do it the shortcut way using the formulas. So let's say we have an angle that goes through the point -4, -3. So I'm going to estimate -4, -3. I think you all agree it's in quadrant 3. I'm going to draw a hypotenuse to the origin. I'm going to draw a right triangle to the x-axis. That's pretty important. You've got to take the point to the origin, and you've got to take the point to the x-axis. I am trying to calculate now this turn by using that reference angle. Okay? I know we went left 4 and down 3 to get there. Now we should be able to figure out the hypotenuse. They call it d, and we do x squared plus y squared. -4 squared is 16, -3 squared is 9. And you can see that d is 5. I hope that's okay. -4 times -4 is a positive 16. -3 times -3 is a positive 9. Square root of 25 is 5. So they picked a nice one to start here with. And we can do all the trig functions from that point using our triple T. Sine would be -3 over 5. Cosine would be -4 over 5. Tangent would be -3 over 4. So from that angle by the origin, this is opposite, this is hypotenuse, This is adjacent, which I have trouble putting a D in there right now. That's nothing new. This is the new way. If we have the point -4, -3, we know that x is -4 and y is -3. If we find D, we can use our new rules. Sine is y over d, cosine is x over d, tangent is y over x. I can do tangent right now. Y over x is -3 over -4, which is 3/4. And if you looked over here, tangent was 3/4. -3 over -4. I put that negative in there. I think I was meant to dash. Now, you get D by doing our formula. X squared plus y squared. I think you can see that D is going to be 5 again. We're doing these same numbers. And you can see now sine is -3 over 5. Same thing as it was over here. Cosine is x, -4 over 5. So that's all these new rules are trying to tell you. Sine is y over d, cosine is x over d, tangent is y over x. Here it is, a little better picture. We're trying to find that turn. And we could use tangent to find the turn if we wanted to. This would give us the reference angle that's right in here. And then you would add 180 to it to get the whole term, okay? So we're using the same things. You could have used any of the trig functions. They decided to use tangent because then we didn't even have to calculate the hypotenuse. All right, let's try another. Well, let's see here. I've got some more. We'll talk about the unit circle. I think what I'm going to do is just make up one more. Let's say we've got -5, 2. So, what's x? -5. What's y? 2. Now let's find d, square root of x squared plus y squared. Again, I'd like you to do it in your head. -5 squared is 25. 2 squared is 4. 25 and 4 is 29. D is the square root of 29. And now if you do sine y over d, it would be 2 over the square root of 29, which is 2 root 29 over 29. Cosine is x over d, which is going to give you 5 over the square root of 29, and it's a -5. Hope you remember how to deal with those radicals. I'm multiplying the top and the bottom by the square root of 29. And then tangent, we already had the answer. It's 2 over -5, because we had x and y. Okay? And what that last slide is telling you, if we really wanted to go and find the turn, we could say, okay, theta is going to be tangent of 2 over -5. And since we're finding theta, we'd have to do the inverse. That's going to give you the reference angle. But for now, we just want you to get used to this y over d, x over d, and y over x. I hope that all makes sense. I'm going to take one quick look here at the summary page. What are the steps? Sketch the graph, reference angle, find sine, cosine, and tangent. Hopefully you're good at positives and negatives. Can the point 2, -2 represent two angles with different directions or amounts of rotation? How are the trig ratios related? So this question I don't really care for. How are the ratios related to the coordinates? So that I do care for. So how does SOHCAHTOA match up with coordinates? Well, sine is what? Y over d. Cosine, x over d. Tangent, y over x. All right, and remember the coordinate is x, y. And how do you find d? Good old Pythagorean theorem. All right, so there's extending your trigonometry. We're going to do more videos that relate to this and go with this. So this is, I hope, not too much. I get a little carried away with these videos because they're so much fun. And for that, I apologize. Thanks again for listening, everybody. There's another video for you. This is Mr. Fogarty signing off, saying I miss you, and good luck with everything. Thank you.